Hi, my name is Brian Cardarella, and my presentation is on doing real-time or real-ish time in Rails. Just some quick self-promotion BS first. So I'm the owner of a consultancy in Boston called Dockyard. We do Rails, Postgres, but we also been doing a lot of Ember.js lately. Ember's awesome. And also, we're organizing a wicked good RubyConf in Boston. We're looking for speakers. We're looking for people to buy tickets. So this is Boston's first Ruby conference. It's going to be in October. If people are interested in coming to the city, please check it out. Okay, so that's a little, going to do this. It's better. Okay, so we're going to start with a history of popular software. Oops. A barely accurate history of popular software. To make a point, this is going to be really bad. First, we started out with IBM. IBM owned the landscape. They had everything. They were the monopoly that was around. And then little guy Microsoft came around and said, "Hey, IBM, you guys are selling the hardware. Why don't you let us sell the software?" And IBM's like, "Sell the software? That's crazy. No one's going to buy that. Okay, go ahead. You can do it." Then Microsoft became very big. And then Microsoft's sitting there, they're doing well, and then Java came along. Java's like, "Hey, yo, you guys are selling the software, we're just going to give it away." And Microsoft's like, "Give it away for free? That's crazy. Go ahead, that's fine." And then Java did very well. They multiplied, many different versions of Java came out. You can tell how cool Java is because the one in the middle has a beeper on his belt, and he's got hair plugs. And then this little guy called Rails came along and said, "Hey, we're going to take this language called Ruby, and we're going to run scripting language on the server." And Java's like, "Scripting language on the server? That's crazy. No one's going to buy into that." And as we all know, Rails became rock stars and ninjas and all that good stuff. And then finally, Node came along, and Node said, "We're going to run JavaScript on the server." And Rails is like, "JavaScript on the server? That's crazy. No one's going to do that." Okay, go ahead. But now we know that Node has done pretty well, and and it lets us know about it quite a bit. So the point here is not so much historical accuracy or any relevance beyond this talk, but more about how when technology or business becomes complacent and fat and happy and where it's sitting, there's opportunity for other people to kind of swoop in and pick up market share or mind share. And that's really what's happened in the past few years with Node and Rails. Real-time is just one of the areas that Node has outpaced Rails. Some of the other places might be I don't think the metrics are really that interesting. People may claim that like NPM has like 5 times as many packages as Ruby gems, and I mean that's a better indicator that it's easier to build those packages than it is that those packages are really worth anything. The other metric I hear a lot is that Node naturally has way more developers than Rails does. I mean, yes, there are developers because JavaScript is the only language on the browser. That is going to mean that people are going to be somewhat comfortable with the language on the server, but the problems you're solving on the server are very different than the problems you're solving on the browser. The language is, at that point, the smallest barrier of entry for solving those problems. In fact, I think the problems are language agnostic, especially the big ones. For a long time, Rails was the innovator, and because of a lot of the work that's been going on for the past few years with first the MERB merge, and it seems like stuff that's been happening lately is more like organization of your applications rather than saying, "Hey, we're going to go and really kind of forge the path in this new direction." But Node has been really hitting that point pretty well. So can Rails scale its features? We're going to take a step back and talk about kind of a primer on what I'll get to later. It's interesting that there's a lot of people in this room, so there's going to be a whole wide span of abilities here. And for the more advanced people, they can probably just tune out for the next few slides. We're going to talk about sockets, because even though Rails devs, especially some advanced Rails devs, they legitimate advanced developers for Rails, they may not have experience doing some of the stuff I'll be talking about because they just haven't touched on it before. So beyond my slides, because my slides will only be good enough for me getting through the rest of the slides towards the end, I highly recommend this book here, Working with TCP Sockets by Jesse Stormer. It's awesome. I don't think it's that much money either. I think it's like $10 or $15 or something like that. He has another book too. I think it's like called Ruby and Unix or something like that. That's also very, very good. So the basics of the sockets for the purposes of the WebSockets I'll get into later is that you have to know that data, when you send it from your client, is broken down into frames. Those frames are then broken down into packets. The packets then travel on the Senator Ted Stephen tubes to the server, and then the packets are constructed into frames, and the data is read from the frames. What we're really after here on a lot of levels is this idea of concurrency. And we want to have not just real time, not just having data pushed to our servers very quickly, but we also want to be able to have our servers handling many, many transactions at the same time, many, many requests at the same time. So the concurrent web servers that are out there that are available, I'm sure a lot of people have seen already, Puma, Rainbow is thin. I like Puma a lot. The reason is Puma, I think, is the smartest about how it handles its memory. There's a graph on the Puma IO website that shows Puma is doing way better than everything else. I don't know how accurate that information is, but if we take that somewhere in the ballpark, the way it works is Puma will actually thread its processes. So rather than forking the process, which just does a flat memory copy, it'll just use Ruby threads, and so it ends up being less costly. So in Rails 4, this is a quote from Nick Gauthier. I got a few things in here from him. Rails 4 is now fully concurrent. There is no full stack lock on a request. If you use a concurrent server like Puma, you can handle many requests at with a single process. So that is, and inside, when we're working with WebSockets, when we're working with server-sent events, we're going to want to get used to working with threads. And this is going to be a whole new world for a lot of Ruby developers as well. You'll have to learn how to write good threaded code. That means observing thread safety practices, being aware of deadlocks, being aware of race conditions. Simple example, this here could produce a race condition. So we're going to say, hey, we're going to create a new thread. We're going to iterate this through 100 times, put out here, and then at the end here, we're going to say over here too. But we don't really have any guarantee which one's going to happen first. So let's see a more complex example. This is an example from an application that we wrote. We have several, you can think of it like chat roulette almost. We have several rooms. Each room can only hold 2 visitors. Visitors are assigned to a room as they join, and when a room fills, the next visitor is assigned to the next available room. So I want to demonstrate this, if you guys will indulge me, with some audience participation. So I'm going to need, can I just get these guys? You guys sit up front, so you're gonna, I'm gonna recruit you guys in. So I need about, give me 4 people. Okay, so imagine, if you will, that there is a pretend room where there only holds 2 people. So you're going to be 1, 2, 3, 4. These requests are coming in. Okay, number 1, how many people are in the room? No, not that room. The room, the pretend room to your right. 0 people. Okay, so you can go in because there's less than 2 people. Go ahead. All right, go a little bit further. All right. All right, now, number 2. How many people are in that room? 1. Okay, now number 3, how many people are in that room? 1. All right, now you both try to join at the same time because you got 2 requests coming in, and now we got a problem. So this is where thread safety comes into play, and a simple fix for thread safety is to introduce some sort of queue so you can, while your requests are still coming in concurrently, you're handling a lot of other things concurrently. When you need to actually make certain parts of your application thread safe, you can introduce a queue. So why don't you guys head back in this direction. All right, so now, number one, how many, I don't know if I need you, sorry. We'll see. Number one, how many people in the room?
0.
All right, 0, you go over there. Number two, how many people in the room? 1. All right, number 2, you go into the queue. And now number 3, now you go in, or sorry, I messed up, sorry. Number 2, you come back. Sorry. Okay, number 2, you head into the queue. Number 3, you head into the queue. You gotta go behind him, it's a queue. All right. Number 4, why don't you go in the queue too, just for the hell of it. All right, so now you're at the front of the queue. We're gonna process you because you're a job. All right, now job, how many people are in the room? 1. Okay, now you can go in because we're handling you one at a time. Number 3, how many people in the room? 2. Okay, now we need to create a new room, so that new room is gonna be over here. And number 4, how many people are in that room to your right? 2, so you gotta come over here. So that's a pretty simple, very easy way to handle thread safety, and it works well for the presentation because I get to kill some time. All right, thank you guys. If you are working with a single Ruby process, you have, a single Ruby server, inside the mutex class, you have a synchronize instance method. You just create a new mutex object, and this synchronizes, it can work as a queue for you. So if you don't have that, then you can work with some sort of external job processor. Inside the world of concurrency, PubSub is going to be your best friend. You will be relying upon it quite a bit. There are, the bottom 2 are probably the more popular ones. For those that don't know, Postgres has PubSub in it, and I like talking about Postgres because Postgres is awesome. It's called Notify Listen instead. The PG gem does have access to this. Redis is probably the easiest. 0MQ is, when I understand, the fastest, but I actually have not used it. So for Rails, the way we've been kind of accomplishing doing this right now is really to go outside of Rails. You could create a server, another app server that sits right next to Rails with either EventMachine or Celluloid. EventMachine has an EM WebSockets plugin. We've done that. I haven't used Celluloid, but it seems to be where people in the EventMachine world are moving towards. Or you can use an outside service like Fay or Pusher and let that handle everything and push it back to Rails, or push it back to the client, rather. The other option is, the people using your apps, they don't really know what's under the hood. So as long as something feels real-time-ish, that might be good enough. And for a long time, a lot of people have been using long polling. And for those unfamiliar with that, this is the gist. You make a asynchronous request to your server. You might give the last time you made this request so you can just get a delta of your data. And then when it's done, it will then set the timeout and repoll again. So it's kind of an infinite loop that just keeps going over and over again, and then we'll populate with data. So in Rails 4, there's been introduced this concept of a Rails metal called ActionControllerLive. ActionControllerLive is a proxy object for the socket. It's exposed by doing response.socket. And anything in Rails allows to control the headers. That's not right. But what you will want to do is modify your headers based upon the type of your response that you're giving back. This would be the API endpoint that you would see for the long polling. And here we're just, again, using the delta on the chat model and getting the history from it and responding with JSON. This might be something that you would see with ActionControllerLive. You're mixing in the module, and then you may or may not be using a thread here and handing it off to some sort of service to process the stream, everything out. On Aaron Patterson's blog, Tenor Lovemaking, he talked about the ActionControllerLive stuff. The most important quote, I think, rather, is that the stream object is meant to quack like an I/O object, which means that if you're familiar with using files and such in Ruby, it's going to be somewhat similar. You have the write method, you have the close method, and you're going to have a read method as well. So this shouldn't be too different from what you've done before. So now we're starting to get into more interesting things. Server-sent events. it allows for one-way communication from your server to the client. These are part of the HTML5 spec, and they're pretty easy to build. So here is something else I stole from Aaron's blog. We are setting the response, that should be easy to see. We're setting the response header to text/event stream. This tells our client that the response is coming back as an evented response. And then the event itself is going to be written as a key value pair that has multiple lines that are split by new lines, and then each event is split by a double new line. In this example, we are writing back a time event, and we are streaming back the time.now data. You can also include an ID. So if your client becomes disconnected from the server for some reason, you will repurpose that ID so that the client can pick up where it last left off. On the bottom code, we're using the event source object, which is how you're creating events or listening for events on the browser. And then we add an event listener, and we give it the event of time, because that's the one we're interested in, and the callback here will allow us to handle the event in some fashion. So I will just demo this pretty quick. Whoa, that's tiny. Let's see here. This will work. OK, so I mean, it's not super interesting, but we're just responding with server time. And this is going to continue to count for 100 seconds, and then it will stop, but we're not going to wait that long. So with ActionControllerLive, it's cool that we have some way to stream back responses. But in Aaron's blog, he admits that in order to get it working, he had to work around Rack quite a bit. What's really nice is that back in January, I think, with Rack 1.5, there was introduced rack.hijack. So Rack Hijack allows us to hijack the raw TCP socket from Rack and then do whatever we want with it, and then allow Rack to continue on. And this is essentially the API here. Inside our Rails environment variable, if our web server, in this case Puma, is Rack Hijack compliant, then the rack.hijack key is going to return true. And then we can call a call on rack.hijack, and this will return the raw TCP socket. If for some reason we need to access that socket later on again, then we can just call rack.hijack_IO. And there's two ways that Rack Hijack is meant to work, but for the purposes here, we're just going to talk about the full hijack. And requests are made to the server. The TCP socket is then taken for your purposes. You can put it into a thread. You probably should put it into a thread to do what I'll be doing next. And then you tell the server to complete the request as normal. You want to respond with just like an empty body and then a 200, just so that Rack can complete. And the thread is alive until you close the socket and kill your thread, essentially. And then it's up to the web server whether or not it's going to allocate new sockets or if it's going to wait until the socket is free. And I also, if people are interested in this, I recommend checking out the Rack spec. Just search for hijack inside of it, and you can find everything having to do with that. So WebSockets. This is the part that really interested me, because I actually haven't used server-sent events, but we use WebSockets quite a bit. And I think that WebSockets and Rack Hijack work really well together. It allows for two-way communication, and there is a WebSocket gem for constructing your WebSocket handshakes and frames that we'll be going into. So if you want to get up and running with this, I recommend that you use the master branch on the WebSocket project. If you, for whatever reason, think that your WebSockets are not fast enough, there is a natively compilable WebSocket gem, but I have not used it. And this is what a handshake construction, incoming and outgoing frame request and response would look like. It's a little bit of code, but we'll show you something in a bit that's much easier. So on the third line, we're getting the socket from Rack Hijack. Fifth line, I'll stop counting lines. But we're going down, we're creating the handshake, and then below that we see handshake.fromRack and then env. This is the reason we want the master branch of the WebSocket gem. It hasn't been pulled into the gem on Ruby gems yet, but recently there was this method added that allows the handshake to construct all the headers properly based upon the rack environment variable. And then we're just writing out to the socket the handshake. The second group here is we're reading from a frame. So when I mentioned frames earlier on in TCP Sockets, this is what we're constructing here. The object itself, we're creating a buffer, and then we're receiving 2,000 bytes from the buffer, from the socket. We're writing that data to the buffer, and then we're going to iterate through the buffer, and we're going to get frames back, and then we can handle the frame data any way we want. Down at the bottom, we are just sending out a message, so it's going to look somewhat similar to the handshake itself. Just to reiterate, we're constructing the header, writing the header to the socket, write data to the socket, read data to the socket, close the socket. I mean, it's not super interesting when you kind of do it quite a bit, but this is the gist of how WebSockets can work in general socket programming. WebSockets on the client. This API is much simpler and should be pretty self-evident. These callbacks fire based upon responses from the server, or yeah, these are all responses from the server, and then the third one is when you're sending data out. And I have some demos to show. So we have a chat demo, and then we have a drawing demo. Both of these are using the same Rails application. They're using WebSockets, and hopefully they won't be really slow because Wi-Fi is not fantastic. Anyway, so we got this chat server here. People can join it if they want, if they're up there. They go to RailsConf 2013.dockyard.com. You'll have the option of clicking on chat or draw. This one might be a little, whoops, just read. This one might be, it's probably goofing up. That doesn't look good. I think that's a Chrome thing. That's even worse. Yeah, I know. That's what I meant to do. And let me try Canary. Okay. So if people join that, we can see you guys. Yeah, there's somebody drawing now. And we can continue going. Once enough people join, the server will crash because there is a memory leak on the server. Yeah, don't draw anything really stupid. Come on. Let me get off of this. All right, and there's people in the chat room. Okay, hello. Anyway, these are pretty simple cases for what we can do with this stuff. The source code is available on GitHub, GitHub dockyard/realtime-rails. The code is really fugly because I put everything in the controller. That's my excuse for not breaking it out. But anyway, it's pretty self-explanatory in what it does. Whoa, everyone's joining. I should have made it actually jump to the bottom. All right, anyway, let's go back. So what we'll notice is that when you're doing applications like this, a pattern begins to emerge from what you're doing, from naturally what you're doing. That pattern ends up being you're capturing events on the client, you're sending those events to the server, and there might be some data normalization going on, and then that message gets blasted out to everyone that's connected. This is why services like Pusher can exist and work so easily, because this is not a really complicated thing that's happening. So the code, actually, you know what? I'll even show you just how ugly it is, just so you can see how much nicer TubeSock makes everything. All right. All right, so this is a big, fat controller method. But I got two threads going on. I've got PubSub happening, and that was it. Anyway, so TubeSock makes things much, much nicer, much easier to work with. TubeSock is a gem written by Nick Gauthier, and the API for TubeSock is going to look much similar to what the WebSocket API looks like on the browser. Inside your action controller method, inside your action rather, you're just going to wrap everything in this hijack block, and you can just use it in the same way you would on the client. I highly recommend TubeSock. So some of the challenges that do exist for for WebSockets right now is Heroku does not support them, at least last time I checked, they don't. It kind of flies in the face of what their business model is. They're bringing down servers and bringing them up all the time. That doesn't really work well when you have persistent connections that need to be there. But it would be nice if the paid instances had that. And Nginx tends to really not want you to do WebSockets. They did introduce HTTP 1.1 support a few months ago. This has the keep alive aspect to it, which is necessary for WebSockets. But by default, Nginx, and this took me way too long to find than it should have, Nginx also has a setting called proxy read timeout that is set for 60 seconds. So if the socket is inactive, if the connection is inactive for 60 seconds, it just kills it. And I had no idea why. It was just dying after a minute every single time, going nuts. But you can bump that up quite a bit. You can bump it up to 24 days. I don't know if you need it that high. It would be nice if there was just an all-around infinite time, or maybe even Nginx might not be the right solution for this. So for the future, it would be nice if Rack Hijack was integrated into ActionControllerLive. Right now, we have two solutions for kind of the same problem. I've offered twice now on the Rails core mailing list to do it, and I've taken my sweet time and haven't done it both times I've offered, and I'm not going to go for a third. So if somebody wants to tackle that, I think that'd be really cool. But with release candidate 1 today for Rails, I don't know if it'd still be on the table for Rails 4, maybe 4.1. And I think, or at least I hope, that having this stuff in there would be validation and some indication that Rails is moving towards a friendlier, like rich client experience for developers. Like I said, I'm getting more and more into Ember. I highly recommend it. It's awesome. And I think having these type of tools available on the server allows your Rails, taking all the tools and everything you've learned doing Rails applications and now applying it to doing these highly responsive asynchronous applications is going to be pretty interesting to see what we come up with over the next few years. I think that's it, and we'll explore it again. If you guys like doing this type of stuff, we're always hiring, and we're looking to do anything like this. So thank you guys very, very much for the time.